Quite a lot. So let's get started. Here's the overall workflow. Now, which is the file that you managed to modify quite a bit, quite a lot, quite a bit, quite a lot. So as mentioned before, yeah, same. So as mentioned before, we have 4 parameters. The lookup table are created from 4-dimensional through sweeping 4 parameters. You know VGS, VDS pretty, right? You know pretty. But we also do the VSB and then channel length and the VSD, which is the file you may need to modify quite a bit. So we'll come back to this file. We'll come back to this file. Once we click the run, we basically generate a netlist called TagSweep.scs spectrum circuit simulation or simulator, simulation SCS. And then we generate this, and then we also we basically. So let's get started. Here's the overall workflow. We have the main MATLAB scripts driving the driver. We have the driver. We have this. Main MATLAB script driving the LUT generation, and this is kept general. So normally you shouldn't modify anything in this file. Instead, any user or process specific parameters are provided via this configuration file, which is the file that you may need to modify quite a bit. You may need to modify quite a bit depending on your application, on your technology, on your application, on your technology. Yeah. So we'll come back to this. We'll come back to this file a bit. We'll come back to this. So we'll come back to this a bit. We'll come back to this file. We'll look into this work. Let's first clarify. So let's first we'll come back before we clarify this. So we'll come back to this file after clarify this overall after clarifying this overall workflow. So yeah, so let's get started. Here's the overall workflow. We have this main MATLAB script driving the LUT generation. Now this file is really kept general, and normally you shouldn't modify anything in this file. Instead, any user or process specific information or parameters are provided via this configuration file, TextSweepConfig, TextSweepConfig, TextSweepRun, TextSweepRun, TextSweepConfig, TextSweepConfig. So this is the file that you may need to modify quite a bit, and we'll come back to this file. So as mentioned before, the LUT is created via four parameters. As mentioned before, as we so the LUT is created via by sweeping four parameters. Yeah, VDS, VGS, VGS, VSV, and channel length. Now to take too much memory. Now we split this sweeping. Now we do in the so now for each so basically for each L and VSV, so we have a for loop in the MATLAB script. Basically we are sweeping L and VSB and VRSB and L. And for each VRSB and L, we generate a netlist called TagSweep.scs. And then in this script, main script, we call the cadence spectral simulator. Of course, we specify the model file in this configuration, and we specify the model file in this configuration. Actually, this model file name path is specified in this configuration, and it will be in this netlist. So it will. So for each VRSB, and we run DC sweep of VGS and VDS, and also noise sweep of VGS and VDS. And once the simulation is done, we use CDS SR and CDS inner SR function to read the data back to MATLAB, because this is in spectrum simulation, right? We have the spectral simulation results, but we need to pass the result to MATLAB, and the function is CDS cadence design system signal reading. No,我就不编了 no, but yeah, it's just something like that. Yeah. So, well, I don't know. It's just something like that. You know what I mean, right? That kind of purpose. Cadence design system, spectrum reading. Yeah, sometimes you may need a CDS inner SR, because there might be some bugs for this kind of tools. So that's one loop. Then you do the next loop for a new set of VSB and L. You run again, you read, and once this loop is done, you save all the results to the lookup table file called nch.mat and pch.mat. Yeah, if it's 40 nanometer, you can use 40 nch, 40 pch. If it's 28, you can use 28 nch, 28 pch. And here, I guess it's a 65 examples. It's an example for 65 nanometer. So this is the overall workflow. Now, so this is the overall workflow. So now let's look into this configuration file. Let's look into this configuration file a bit. Let's look into this configuration file a bit. I can just run one sweep or two sweep. So it can be pretty fast. I can just let it run, and then, yeah. So let's look into this configuration. So then let's look into this. So then let's look into this. So then let's look into this configuration file. And once all these simulations, all these loops are completed, the data for the data set for each transistor is stored in the lookup table output files. Yeah. So so let's look into this configuration file. Let's look into this tag sweep config. Tag sweep config. Yeah, tag sweep config. Yeah, tag sweep config. We have quite a few sections. We have, this is basically the configuration file. We have quite a few sections. It has a few sections. Parameters, sweeping parameters, variable mapping, and then the simulation notch list. Yeah, it actually, and then this variable mapping. Yeah, in Celsius, in F, in degree C, in F or degree C. So it can be in degree C or F, degree C. But this is temperature in degree F. Temperature in degree F. If you want to do in degree C, you have to minus this number by 273. Yeah. So here, just these are the files for sure you need to modify, depending on the technology you are using, and depending on the corner you want to characterize. And here, yeah, it's TT corner. Also, the second file typically, yeah, it's something like unique to TSMC. If you use other technologies like Global Foundry, typically the second file is really kind of like optional. And specifically for TSMC, we have this pre-simul meaning, yeah, with this you actually added this terminal resistance to your transistor. Yeah, well, even its intrinsic resistor, you have this. So there are some terminal resistance, and for RF application, this does matter. For our low frequency dynamic, many times you don't see any difference in your results, but for RF, you do care about this. Yeah, it's fine. You don't. But anyway, when you read your PDK documentation, yeah, it says this one. When you do this one, you even for your pre-layout simulation, you added your intrinsic terminal resistance, and then Now this is important. This is really important. Temperature in degree F, and then this is the file name. This is the file name that you want to save. Yeah, just to make it easy to interpret. It can be any. Ideally, in theory, it can be anything, but you want to give a name that can easily interpret. But you want to give a name that can easily. So we have quite a few. Sections. So then let's look into this configuration file, which includes several sections, which includes several sections. So first of all, we defining the path, defining the file path, define the simulator, the syntax, the sweep range, the parameter sweep range, step size, the template, the netlist templates, as well as the mapping, and also the mapping from simulator outputs variables to MATLAB variables. So let's briefly discuss this. So just let me know if you have any questions. Just stop me if you have any questions. So let's look into this configuration file. Yeah, including server sec with including server sections, server sections. The file path, models and file paths, server sections, models, PDK models, models, and the file paths, to the simulator. PDK model, PDK info, PDK model info, PDK models, and simulator file paths, and simulator file paths, and simulator file paths, simulator file paths, sweep parameters, sweeping parameters, and step size, sweeping parameters, step size, ranges, 4 parameters to sweep, parameters to sweep, and their step size, minimum, maximum, and their range. Parameters to sweep, their step size, and sweep, and a sweeping range, and a sweep range, and 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 sweep range. Yeah, and sweep range. Yeah, and sweep range. So I may miss any. So if you have any, yeah, I just follow my flow. So do this. So if you have any questions, just stop me. I just follow my flow and based on my own reasoning. So maybe something is not making sense to you. And for that, just stop me and we can discuss. Yeah, sweep range. Yeah, one thing pay attention to is, yeah, you need to be careful depending on your technology, and this is something you really need to think about it depending on your technology, and this is something you really need to think about it, and this is really something, and this is really some sweep range and sweep range. And parameters to sweep, parameters to sweep, parameters to sweep. Um, Mapping from simulation output variables to MATLAB variables. Yeah. Netlist template, netlist template, netlist, netlist to writes, netlist to writes, netlist to writes, and and the mapping from spectral simulation outputs to MATLAB variables, and the mapping and after the simulation and after the simulation and the mapping from spectral simulator output variables to MATLAB variables. So this is something that. So let's dive in. So let's dive in each section. So let's dive in. So let's dive in. Of course, and yeah, I can just do huge step for now because I don't need to. Yeah, yeah. I can. It's almost no step. Yeah, yeah, yeah. Just two steps. So basically, you are done. You are done. You are done. You are done. And here I did a lot of. Oh, something goes wrong. Yeah, this does happen. Yeah, even you did a countless. You did a lot. So let's dive in each section. So let's dive in each. Let's dive into each section. Each section. Let's dive in into each section. Yeah, yeah. Then you simply run. You simply run, and then just pray, and then just pray. Um, and hopefully one-time success. I pray for one-time success, and then just pray for one-time success. It's fine. So we target for one-time silicon success, but not for this kind of things. This kind of things you can, yeah. We target for one-time silicon success. This kind of thing is fine. Many times you deliberately do something, then to see, right? And it's super difficult to get to the one-time success, even for very experienced designers. And also, there's simply not much point in, right? Many times, just this might save you, not even, yeah, might be even faster. Instead of check it thoroughly, very carefully from the very beginning, very first line, second, third, and all the way, and check all the files, right? This seems many times you click, you can immediately locate instead of looking into. Yeah. So anyway, let's see. Anyway, let's see. Let's see. Um, yeah. Okay. So today we are going to look into the look. Uh, dive a bit into the. We're going to dive a bit. Going to dive a bit. Dive a bit. We are going to dive a bit into the lookup table generation. Now, some people may wonder, why do we need to do this if we have a lookup table already? Well, there are multiple reasons, but the major one is that we want you guys to be familiar with this process. Um, yeah, so we to feel comfortable with this process. So next time when you need to do this, so next time when you need to do, well, there are multiple reasons. Well, multiple reasons. But the major one, the major one, but is to make you make sure is to make you be comfortable with this process, with make you be comfortable with this process. So next time, so next time when you needed to do it, don't panic. You're not panic. You're not panic. Yeah, just follow the steps and and that's it. Because oftentimes people avoid doing this simply because they don't know how to do it. But because many times if they don't know how to do it, because many times if they don't know how to, if people don't know how to do it, they simply shy away from this. Because many times people simply shy away from this. People simply shy away because many times when people needs to work in a different technology or with different VTs, they simply shy away from doing this because they don't know how to do this. And guess what? They become a spice monkey. And it would be really bad, right? If you do that after taking these lectures. I mean, then what's the point? What's the point, right? Then what's the point of taking these lectures? So yeah, and that's perhaps the major reason why we arranged this demo. to show you the step-by-step process on generating the LUT. So that next time when you do it, it's not a big deal. When you do it, you just do it, and not a big, it's yeah, just follow a few steps, then done. Then so next time when you need to do it, you just do it and follow the steps. You just reach your destination, and maybe there's some iterations, but it's fine. But it's not a big deal. So let's get started. Here's the overall workflow. We have this main MATLAB script driving the LUT generation. Yeah. So we have this driving the LUT generation. Now this file is really kept general. Normally you shouldn't modify anything in this general file. Now any user or process specific parameters or information are provided in this configuration file. So this is the file that you may need to modify quite a lot, depending on your technology, depending on your technology, your design specification, your design requirements, your VTs. I mean, yeah, your VTs. So we'll come back to so let's your VTs. So as we said, so we'll come back to this. So we'll come back to this. So we'll come back to this a bit later. So we'll come back to this. So we'll come back to this. So we'll come back to this. So the LUT is created by sweeping 4 parameters. You all know this VGS and VDS, VGS and VDS story. We all know, yeah, you might be quiet, but then another 2 design ops is the VSB and the channel length. Okay. Channel length. So the LUT is so we'll come back to this a bit late. So we'll come back to this. So we'll come back to this file. We'll come back to this file. So we'll come back to this file. Now, the LUT is generated by sweeping 4 parameters: VGS, VDS, VSB, and a channel length. Yeah, you can and sweeping do 4 loops for the sweeping in Cadence. You can do that, yeah, perhaps, although I've never do that. But 3 for sure, I know it's feasible. But again, that's not memory efficient. So what people typically do is they do 2 loops, they do 2 for loops in Cadence and another 2 for loops in MATLAB. So here in MATLAB, we sweep VSB and a channel length, and for each sweeping, we generate a netlist called TechSweep.scs, and then we also in this script, after generating this netlist, we call the Cadence Spectral Simulator. to run the simulation based on this netlist. And of course, we need the PDK model file, and that's specified in this. And once we somehow then passed it to this, yeah. So and then we simulate, we do the sweeping in cadence spectrum, essentially two loops in cadence spectrum. And here we do both DC and noise by sweeping VGS and VDS based on your here. And once this is done, we have the simulation results in cadence spectrum formats, which is quite different from MATLAB formats, and we need and we want to do our processing in MATLAB, so we save the data, we transfer the data from cadence spectrum to MATLAB by using this function CDS SRR, cadence design system spectrum. No, just my guess, maybe I know CDS for sure is CDS, but that's spectrum. So well, but you know what I mean. It's just a function to read the data from cadence spectrum to MATLAB. Okay. Sometimes you may need CDS inner SRR because this might be bugging. Yeah, this is something may happen in your debugging phase because the tools are written by people, the software. Yeah, and people they make mistakes. So you just have to try. You just have to try. You just have to try. So that's for one loop, for one VLSP and L. Then you sweep them, get another VLSP and L. Then you save the data again, get the data. So when these loops are done or completed, we save all those data to MATLAB files called nch.mat or pch.mat. Yeah, this is 65 because we're using because I think this is for using 65 nanometer technology. It can be 40, 28, 22, depending on your specific technology. Okay. So let's dive. So then let's dive into this configuration file a bit, which since it's the one that you are going to modify quite a bit, perhaps. So here, I just follow my flow, and so if you have any, just stop me. Just stop. If you have any questions, just stop me and let's clarify. I don't know. Well, simple answer is I don't know for now, but I'll come back to you. I don't know for now. The simple answer is I don't know for now. So I'll come back to really. Yeah.